Okay, I hope I'm audible to all my students who are attending this particular lecture for the Mathematics for Business Economics Part 1. In this particular lecture, I'm going to discuss with all students the Delhi University 2023 question paper, which has come up for the Mathematics for Business Economics 1 course. And this lecture is for all those students who are pursuing Bachelor's in Business Economics, BBE, from University of Delhi. So this is the question paper all students can currently see on your screens. The name of the paper is Mathematics for Business Economics 1. And this is for all those students pursuing BA Honors Business Economics from University of Delhi. I'm going to start with the discussion of this particular paper in this lecture. Okay. And if you look at the question paper, all questions have to be attempted. So there is no internal, there is no choice in the question paper. You have to attempt all questions. And you are allowed a simple calculator in the exam. Okay. And for questions which are based on concepts of present discounted value or compound interest, you will be provided the present value tables also in the exam, in the university exam. So if I scroll down, I'm going to start with the discussion of question 1 in this particular lecture. So let's start with the discussion of this particular 2023 question paper. So within question 1, let's look at part A. Consider the following function f of x is equal to 1 minus 2 to the power minus x. First part asks us to draw a rough sketch of the graph. Then we need to find the domain and range of this function. And then the third part asks us what happens to this function when x becomes very large and very small. That means I need to find the limits also. When x becomes very large, that means when x tends to plus infinity, and when x becomes very small, when I can say when x is tending to 0. Okay, so let's quickly solve this particular question. Let me come to the whiteboard. I am just writing the main heading for completeness. We are looking at Delhi University exam 2023. Name of the course, Mathematics for Business Economics. Mathematics for Business Economics, Part 1. And this is for all those students who are pursuing BBE honors from University of Delhi. We are looking at question number 1. Within question number 1, we are looking at part 1. We are given the function f of x is equal to 1 minus 2 to the power minus x, which I can also write as 1 minus 1 over 2 to the power x. Remember, when I take the reciprocal of 2 to the power minus x, it becomes 1 over 2 to the power x. And now to draw a rough sketch, I can take some values. So let's take some values of x and correspondingly f of x. When x is 0, f of x will be 1 minus 1 over 2 to the power 0. 2 to the power 0 is 1, 1 minus 1 is 0. When x takes the value 1, f of x will take the value 1 minus half, which is half. When x takes the value 2, f of x takes the value 1 minus 1 over 4, which is 3 over 4. When x takes the value 3, f of x will take the value 1 minus 1 over, let me do that, 1 minus 1 over 2 cube, which is 1 minus 1 over 8, which is 7 over 8. And now let me also see negative values of x. When x takes the value minus 1, f of x will take what value? Let me quickly solve for that. So this is going to be 1 minus 1 over 2 to the power minus 1, which I can write as 1 minus 2, which is minus 1. When x takes the value minus 2, f of x will take the value 1 minus 1 over 2 to the power minus 2, which is 1 minus 2 square, which is 1 minus 4, which is minus 3, and so on. So these are the values using which I can draw a rough sketch of this graph. Using these values, I can just plot a rough sketch of this particular graph. So erasing this off, let's plot a rough sketch. Let us see how the shape of this graph looks like. So I can draw a Cartesian graph. Okay, and I'm not using any scale, so my graph is only going to be approximately correct. This is x, this is f of x. The values of x are 0 with 1 centimeter gap, 1, 2, 3, 4, and so on. Similarly, -1, -2, -3, -4 with 1 centimeter gap. And for f of x axis, I can take my maximum value is 2 and my minimum value is going to -3. So I can take 1, 2, 3 here, and here I can take -1, -2, -3. Let's plot the graph. When x is 0, f of x is also 0. When x is 1, f of x is half. So 1 and half. When x is 2, 3 by 4. That means 0.75. Somewhere here. When x is 3, f of x is 7 over 8. How much is 7 over 8? 7 divided by 8 is 0.875. Okay, 7 by 8 is 0.875, so somewhere here. And similarly, I can plot the other part as well. When x is -1, y is also -1. So -1 and -1. When x is -2, y is f of x is -3. So my graph kind of looks like this. This is how my graph looks like. These are all the points in blue color, which I have plotted, and this is how my rough sketch of this graph looks like. Okay, so hoping all students have understood this. And now let us find the domain and range as well. Now remember guys, domain denotes set of all values taken by x and range denotes set of all values taken. So to find the domain, f of x should be well defined. It should not be plus or minus infinity. Now what makes it not defined? So if this is 0, if this is 0, then it will not be, I can say it will not be well defined. So if I take x as minus infinity, I can say if x is equal to infinity, let's say if x is infinity, then this will be 1 minus 1 over 2 to the power infinity, which will be 1 minus 1 over infinity, which is 1. This is fine. But if x is minus infinity, if x takes the value minus infinity, then it's going to be 1 minus 1 over 2 to the power minus infinity, which I can write as 1 minus 2 to the power infinity, which is 1 minus 2 to the power infinity is infinity. So this is not defined. This is not defined. That means x cannot take the value minus infinity. I'm repeating it again. If x takes the value infinity, see, between infinity and minus infinity, you take any number, your function f of x is defined. So I can write between minus infinity and infinity, for x taking values, I can write this more clearly. Let me erase this off. I can write for x taking values between minus infinity and plus infinity, f of x is well defined. And even if x takes the value infinity, again f of x is well defined, because for x equal to infinity, if I plug it, I get 1 minus 1 over 2 to the power infinity, which is 1 minus 1 over infinity, which is 1. But the moment I take x as minus infinity, that is where the problem comes. Because if I take x as minus infinity, it will be 1 minus 1 over 2 to the power minus infinity. 1 over 2 to the power minus infinity, I can write as 2 to the power infinity if I take the reciprocal, and 2 to the power infinity is infinity, 1 minus infinity is not defined. So I can say that the domain is what? Domain is all values of x, except x equal to minus infinity, except x equal to minus infinity. That means the function f of x given to us in the question is defined for all values of x except x equal to minus infinity. Okay, and now let's calculate the range also. So to calculate the range, I can see first of all how the function is behaving for very large values of x and for small values of x. So let's work that out. If I erase this particular part now, I'm erasing this table. Let us calculate the limit of this now when x becomes very large and small. So I'm calculating the limits for all students. So as x tends to infinity, that means as x becomes very large, what is going to be my limit? Limit as x tends to infinity f of x, which is limit as x tends to infinity. What is f of x? 1 minus 1 over 2 to the power x. I can write this like this, right? So this is 1 minus 1 over 2 to the power x. Put x as infinity. So this will be 1 minus 1 over 2 to the power infinity, which will be 1 minus 1 over 2 to the power infinity is infinity. And 1 minus 1 over infinity is 0. So 1 minus 0 is 1. That means I can write that as x tends to infinity, f of x tends to 1. And now let us see what happens as x tends to 0. Obviously, I will not take x tending to minus infinity because we know that when x tends to minus infinity, from here the function is not defined. When x is tending to minus infinity, the function is not defined. So I am taking as x tends to 0. As x tends to 0, that means as x becomes small. So we calculate limit as x tends to 0 f of x. This is going to be limit as x tends to 0. F of x is 1 minus 1 over 2 to the power x. Put x as 0. So 1 minus 1 over 2 to the power 0. This is 2 to the power 0 is 1. So 1 minus 1 is 0. So I can write that as x tends to 0, f of x tends to 0. So what is my range? My range is the values between 0 and 1. When x is exactly 0, you can see the range is 0. And when x is tending to infinity, the function f of x is tending to 1. So my range is 0 to 1. See, I'm circling it in yellow color. As we have shown that as x tends to infinity, f of x is tending to 1. And x can tend to infinity, x can be equal to infinity, because remember the domain was what? The domain for this function was all values of x except minus infinity. That means the domain, in the domain, x can take the value infinity. I'm repeating it. In the domain, x can take the value infinity. X cannot take the value minus infinity. If you look at the domain I wrote, it was set of all values of x except minus infinity. That means x can take the value infinity. And when x takes the value infinity, f of x takes the value 1. That means my range includes 1. And as x tends to 0, my f of x is tending also to 0. So range is from 0 to 1. Okay, so with this, we are done with question 1, part 1 complete. I have drawn a rough sketch of the graph. I have found the domain and range also, and I have shown what happens to the function when it becomes very large and very small. So I hope all students have understood this. Let's solve question number B. in a class of 50 students numbered 1 to 50, all the even numbered students opt for physics. Those whose numbers are divisible by 5 opt for chemistry, and those whose numbers are divisible by 7 opt for maths. How many opt for none of these three subjects? So this is a very interesting question. So let's quickly solve this particular question. Okay, so first of all, let me come to the whiteboard and let me write this for our students. I'm erasing this off. Question 1, we are looking at part B. Okay, so total number of students are given to us as, total number of students in the class is 50. Okay, number of students who opt for physics, number of students who opt for physics is even numbered students. How many even numbered students are there? How many even numbers from 1 to 50? From 1 to 50, how many even numbers I have? 25. Even numbers are 25. See, 2, 4, 6, 8, count till 48 and 50 as the last even number. You have 25 even numbers from 1 to 50. So, number of students who are studying physics is 25. And those whose numbers are divisible by 5. So, I can write, I can first of all write here that which are all even numbered students. All even numbered students. Which are how much? 25. Number of students who opt for chemistry are all those whose numbers are divisible by 5. Whose numbers are divisible by 5. How many numbers are divisible by 5? So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. How many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means number of students opting for chemistry is 10. Then number of students who like maths, who opt for maths, numbers divisible by 7, whose numbers are divisible by 7, whose numbers are divisible by 7. How many are divisible by 7? 7, 14, 21, 28, 35, then we have 42, and then we have 49. How many are there? 1, 2, 3, 4, 5, 6, 7. So n of m is 7. So now I can draw Venn diagrams. This is my Venn diagram. This is my universal set. Okay, it includes physics, chemistry, and maths. Physics, chemistry, maths. Number of students who like physics who opt for physics are 25. Who opt for chemistry are 10. Maths 7. Now, how many are going to opt for physics? How many are going to opt for all three? Let's find out how many will opt for all three. That means it should be an even number also. It should be divisible by 5 also and 7 also. Now let us see how many of these numbers are divisible by both 5 and 7. Because without the Venn diagram, we cannot solve this particular question. We have to draw the Venn diagram in order to solve this particular problem. So there are 0 students you can see. So number of students who like who opt for both physics and chemistry. Number of students who opt for physics and chemistry are 0. Because there is no even number which is divisible by 5 also and 7 also. So I can write this is 0. I mean n of, let me correct myself, number of students who opt for physics, chemistry and maths, all three, is 0. So this is 0, guys. Because you can see that there is no number which is an even number also and divisible by 5 and 7 both. That means the intersection of all these three, N of P intersection C intersection M would mean all those numbers which are even and divisible by 5 and 7. There is no even number divisible by 5. No even number divisible by 5 and 7. Now, what are the number of students who opt for physics and chemistry? That means even number and divisible by 5. So this is an even number divisible by 5, 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 and even number divisible by 5. How many are there? 1, 2, 3, 4, 5. That means this is 5. So I can write this is 5. How many numbers like chemistry and maths? Chemistry and maths means divisible by 5 and 7. How many numbers are divisible by 5 and 7? Let's look at the intersection of these two. Is there a number? Only 35. See, 35 is the only common between them. 35 is divisible by 7 also. 35 is divisible by 5. So there is no other number. So I can say this is 1. So this is 1. I'm filling up the Venn diagram also simultaneously. Then number of students who opt for physics and maths. N of P intersection M. That means it should be an even number and it should be divisible by 7. So 1, this is an even number. 14 is an even number divisible by 7. Then 28 is an even number divisible by 7. Then 42 is an even number divisible by 7. So 3. This I can write is 3. And now the rest I can find out. The whole physics is 25. So 5 plus 0 plus 3 is 8. 25 minus 8 is 17. So this is 17. Remember, the whole circle should make it 25. Similarly, for chemistry, the total is 10. I already have 5 and 1. So 6, 10 minus 6 is 4. For maths, I already have the sum as 7. 3 and 1 are already there. So 7 minus 3 plus 1 is 7 minus 4, which is 3. And now the class contains how many students? Class contains 50 students. Now, what was the question asking us? How many opt for none of the 3 subjects? That means none of the 3 subjects means outside the Venn diagram, outside this shaded area I'm drawing. The area I'm shading likes none of the 3, opts for none of the 3. That means from 50, I'm going to subtract the internal circle. So I can erase all this and I can write number of students who opt for none of the 3 subjects. Number of students who opt for none of the 3 subjects is, from 50, I subtract 17 plus 5 plus 4 plus 3 plus 0 plus 1 plus 3. That means this plus this plus this plus this plus this plus this plus this. What do I get? It's 50 minus 17 plus 5, 22, plus 4, 26, plus 3, 29, 30, and 33. My answer is 50 minus 33, which is 70. This is my answer. 17 students in the class opt for none of the 3 subjects, physics, chemistry, and maths. Okay, so hoping students have understood how we have solved this. This is where I stop in this particular lecture. We have solved question 1 part A and B in this particular lecture. In the next lecture, I'm going to start with the discussion of question 1 part C. This is something I intend to solve in the next lecture. So I stop in this lecture. I hope all students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.